Hi, my name is Will Sitch. I'm the Business Development Manager for BERT products here in the Americas. We're at IDF today talking about our next generation JBERT, suitable for testing USB 3.1 SuperSpeed devices, receiver test for both 5 gigabit per second and 10 gigabit per second devices. The next generation JBERT, the M8020 JBERT shown here, is suitable for USB 3.1 SuperSpeed. We can analyze coded, scrambled, and retimed data with both symbol error rate and frame error rate measurements at both 5 and 10 gigabits per second. The integrated de-emphasis and clock recovery allow us to do channel equalization on the fly, and we can also do clock compensation for testing elastic buffers. So we can add or remove skip order sets in data encoded with 8B10B for 5 gig USB or 128 132-bit encoding for 10 gig USB. We have a full complement of stress jitters, including random jitter, sinusoidal jitter, and of course spread spectrum clocking and ISI additions in order to generate a stressed eye for compliant stress testing. There are a few challenges for testing USB receivers. In this case, when we're doing a jitter tolerance test, we need to deliver the perfect combination of stresses. Now we start with a stressed clock, a spread spectrum clock, chirping the clock frequency, and we add a number of different impairments onto it, including random jitter and both high and low modulated sinusoidal jitter. We can add some common and differential mode sinusoidal interference, which will close the eye vertically, and then we can deliver the perfectly calibrated stressed eye for performing a jitter tolerance sweep or testing your device to the standard specifications. The second challenge with testing USB receivers is that at 5 gig and 10 gig, the USB signaling is encoded in a different manner. For 5 gig USB we use 8B10B, and for 10 gig USB we use 128 132-bit encoding. Now the M8020 JBERT is capable of both encoding with 8B10B and 128 132, but also handling the scrambler requirements of the payload packages. Here in the sequence editor, you see the number of different blocks that we can add, including the LFPS sequences to signal between the device and the test instrument whether or not the test is going to be at 5 or 10 gig, and also the other blocks including skip order sets, which can be both added and removed by this instrument at both speeds at both encoding types. So now that we have the ability to inject lots of different types of jitter and to encode and decode the bits and packets that are being sent with USB, we can use the symbol error rate and frame error rate measurement capability of the M8020 JBERT to run a jitter tolerance test. So this is a jitter tolerance test running at USB 3.0 5 gig on a SuperSpeed device, and we can change the impairments that are stressing the device along with the swept sinusoidal jitter, and for characterization purposes the data that we collect here is invaluable. We can characterize at what point the device's CDR is beginning to fail. We can see whether in-band or out-of-bound jitter is stressing the device more, and with the tools and software available to you through the M8020 JBERT, you can quickly and accurately characterize your device and make valuable measurements that allow you to bring your latest product to market faster and quicker with fewer problems. The Keysight M8020 JBERT is an excellent choice for testing USB 3.1 receivers. You can do all kinds of cool things like inject fully compliant jitter, do a skip order set addition and removal at both 5 and 10 gig, handle the different encoding and scrambling requirements of the two different speeds, and quickly and accurately test your device using this software and this small integrated hardware. Thanks again for joining me. Have a great day.